Hello, I'm Amara Razgas with Consulting Specifying Engineer, and I'm here today with two experts to talk about hospitals and healthcare facilities. Josh Smith is a mechanical engineer at Henderson Engineers. As part of the health sector of the firm, he designs building systems, prepares design documents, and helps coordinate tasks and procedures on healthcare facility projects. John Flan has more than a decade of experience undertaking mechanical system design projects for healthcare facilities, including master planning, new construction, remodels, and redesigns. As a healthcare sector practice manager and principal at Henderson Engineers, he oversees up-and-coming designers, manages production systems, standards, and processes, and helps spearhead business development, innovation, and sustainability initiatives. It's great to have you here today.
Thanks. Good to be here.
All right. So, John, we're going to kick off this topic with you. Decarbonization and full electrification are moving from buzzwords to concepts that are being legitimately discussed and debated on a large percentage of new opportunities and projects. What are some of the challenges and solutions associated with building electrification, specifically in healthcare?
So it's kind of important to even understand where the electrification kind of trend and everything started. And I caution even using the word trend. It's really been an evolution as to how we've looked at energy being used on a specific site, how resilient and efficient that energy is as far as used on the site. And then we almost put blinders on for a little bit at that point, historically speaking. It was kind of more of what's that site intensity? And a good example on where gas at one point actually ended up being more attractive than electrical energy on site was based on transmission losses. 1 cubic foot of natural gas at a processing plant is still 1 cubic foot of natural gas on my site. So when I burn that, there's no transmission loss of efficiency. Whereas electrical, you end up suffering about a 60% kind of, that's a good ballpark transmission loss. So if I'm using 1 kW of electrical energy on my site, it takes upwards of 3 kW at the actual power plant in order to deliver that to me, just based on the windings losses, transformer losses, and then conductor losses. So what we've done as an overall industry, and even within the healthcare market, is looked at it more on a total cycle of where that electron's coming from and how clean that electron is that we want to end up using. Gas, naturally, we're going to burn it. We're going to throw it into the atmosphere. It's not very clean at that point. Whereas electrical, it's already in the wire. It really comes down to where the grid is getting that sourced electron. As more renewable resources and renewable energy starts actually being applied to the grid, it becomes a much greener source for us. So we can actually look at that as a much more carbon neutral way of doing things, rather than what may have been more efficient from a dollar perspective, as far as bringing natural gas onto the site and then burning it in an efficient way to create those high temperature systems that we need within healthcare. Healthcare in general does require a little bit more energy intensity than your typical building in a few key ways that drive electrification. That's mainly in your sterilization processes, your humidification processes, your general heating, especially when it comes down to ventilation and outside air. So these require a high temperature heat source, especially whenever it comes down to steam generation and everything. So generating that steam with gas when it's readily abundant used to be this tried true method, and we would just concentrate on the efficiency of that gas. Now we need to kind of shift our mentality a little bit and see where can we apply electrical source energy into that process, still get what we need to get as far as humidification, steam, sterilization, but understand where that process really occurs. It started pushing a lot more into the master planning and overall kind of conceptual planning as we go forward within healthcare. We already know that we've got buildings that are built, systems that are in place, things that we can manipulate here and there as far as efficiency, but our eye to the future, what decisions do we need to be cognizant of now to make sure that in 5 and 10 years, we're still meeting these overall goals of electrification and reduced energy. It becomes kind of this total timeline sort of process that that you look at, and it really ends up being geared more towards the environmental health aspect of things and that building health aspect of things.
Yeah, and even the human health aspect. I think that's what we're seeing a lot lately. Historically, we've treated healthcare as the treatment of a patient in a building. And what we're finding is that we're really, really good at designing those buildings to be really healthy for the patient, but maybe those buildings aren't very healthy for the environment or for the surrounding communities. Those buildings, historically have been high in greenhouse gas emissions. They have heavy carbon footprints. They have, and they're just not overall healthy, especially like if you're burning natural gas, that can have direct impacts to the air quality in the surrounding communities. So if we have a building where someone's going to get asthma treated, maybe that building is contributing to asthma and specifically increasing asthma rates. There's a lot of research that shows as climate change gets worse and worse, we're going to see increased asthma rates, increased allergies, and even potentially future pandemics. So that really lends itself to, really pushing for electrification, not just as a growing trend, but as a continuing trend.
Okay. So Josh, let's kind of consider respiratory issues. What trends in the healthcare space is Henderson seeing when it comes to inpatient versus outpatient electrification? And then wrap that all around COVID-19 and the respiratory issues involved there. What are those overall trends of inpatient versus outpatient post-COVID-19?
Yeah. So from an MEP side and kind of from an architectural side, we treat inpatient versus outpatient design pretty differently. And with electrification, that's also true. We take a pretty different approach. Outpatient doesn't have the high air changes like John was saying. It doesn't have the sterilization requirements. It doesn't have the typically doesn't have the humidity requirements that inpatient does. And so it really kind of lends itself, and we see it as a more direct path towards electrification. From a planning side, it also, a lot of times they don't have the large central plants. So going in and renovating also becomes much easier from an electrification standpoint. And it really lends itself to using the new technologies that we're seeing. Heat pumps and heat pump technology has taken huge steps forward in the past couple of years. Electric boilers, electric water heaters, we're seeing those on way more projects now. And so we're really trying to use those technologies and pushing them forward on our outpatient projects. But that doesn't mean we can't do electrification on the inpatient side as well. We just had a project in Washington State. It has several ORs. It's a critical access hospital, and they've got even a compounding pharmacy. And they pursued full electrification. And we use technologies like electric water heaters, electric boilers, heat pump technology, all that stuff. And they were successful in reaching electrification. So it's doable and it's being done right now. From a COVID side, to answer the second part of your question, we're seeing the decentralization of healthcare. That's probably the biggest trend we're seeing. A lot of the services that you traditionally go to an inpatient hospital for, we're seeing them now in more outpatient settings. We're seeing ambulatory surgery center being much more frequent. We're seeing medtail projects really increase. That's retail and medical services combined. And so we're really seeing all those services kind of spread out. We kind of think it's kind of for two reasons. One is that there's a lot of nervousness associated with entering an inpatient hospital during COVID. And the other is convenience. We want everything quicker and faster. And so we're really seeing that as a growing trend that we're innovating around.
Cool. Okay. Thank you. So we talked about the changes we're seeing in the healthcare market. How has COVID-19 specifically affected IAQ or indoor air quality in inpatient versus outpatient? John, do you have any feedback on that one?
Yeah. So it's been an interesting ride through COVID. The tried true methods that we still have on maintaining a proper indoor environment, the technology has adjusted somewhat, but it's not been a holistic change. It's really been, where do we end up wanting to apply it? So historically speaking, within a true hospital setting, you would look at areas of patient congregation and that potential source of transmission vector, right? So in your ED waiting room is a great example. You're going there because you don't know what's wrong with you. You're walking through the door and the staff doesn't know what's wrong with you, but you need to sit in this room with a whole bunch of other people who also don't know what's wrong with them. So that was a primary source where we would look at either exhausting all of that air, or making sure that we have some very robust filtration for that air before we re-entrain it into the rest of the system, just to mitigate or at least moderate as much as we can of that transmission vector. You'd also see it in radiology waiting rooms. That's where it was required as far as the FGI requirements stipulated. We're starting to see that open up a little bit more. Radiology, again, it was kind of similar to the ED. You would have a lot of bronchoscopy and interventional radiology occurring in there where it could be a tuberculosis kind of item or something else that's interior and respiratory borne. So they wanted to make sure that anybody that was incidentally going there to also have imaging of their broken elbow or something was also kind of being protected. But as you back that in to primary entry lobbies of just even visitors coming through the corridor systems and that internal kind of transportation network, the elevators and the vertical conveyance systems for patients, you can start seeing where that it's not a very pretty word, but where that kind of patient to patient sort of cross contamination can occur a little bit more. So we're starting to see some more focus on some of those areas, making sure that we do have a little bit more robust filtration on the air handling systems that might be serving the corridors, treating the primary entry and even visitor lobbies very similar to what we would as far as an emergency department lobby or something similar like that. By and large, it's really just a targeted look on where we can impact that change and make it a little bit safer, right? In the outpatient side, it's been a little bit easier but different, right? So a children's clinic is another good example. It used to be that there would just be one waiting room for a children's clinic. You know, it'd be a primary care physician or something like that. You'd come in, there'd be a reception desk, you'd have one little open waiting room, and then you'd go back whenever you were called to the exam room.
Yeah.
At the advent of COVID and everything, we very quickly saw even projects that were in construction get pulled back a little bit and say, how can we create a moderate separation between these waiting spaces so that we can have one where it's you're here for an injury that we know can't be transmitted to other patients versus you're here for a checkup or something else going on that might be a transmissible disease. How can we properly separate those systems or at least reduce the transmission potential between those patient flows? The other side of it that we started seeing, and this even goes into the medtail component that Josh mentioned earlier, we're starting to see a lot of these outpatient type medical facilities going into what was previously a retail center, you know, into more of the strip mall, the big box stores, the office buildings that weren't really medical office buildings, but they can still support what needs to be done. In doing that, what we've noticed is that we don't need to waste, and I'll use waste kind of on purpose, but we don't need to waste energy all day, every day doing extra filtration and extra ventilation for those spaces. But we do want to make sure that those systems can easily be modified if something comes up in the future. If we hit another wave of a new strain of COVID or anything, we want to make sure that some of these spaces, especially in that medtail environment, can accept a more robust, instead of maybe a MERV 10, maybe we go in with a MERV 14 filtration system during that wave. Maybe we increase the outside air just for that wave that we're dealing with, that surge. And maybe we even relax some of our indoor environmental qualities slightly, you know, so maybe instead of 69 and 70 degrees in the exam spaces, we cognizantly look at that, discuss it with the owners, the users, infection control personnel, and say, maybe 71 to 72 is okay when we're in that surge situation, as long as we all understand why the system is operating that way. And while it might be slightly warmer, it's actually a more protected environment because it's being overventilated. We have a lot more fresh air that we're really washing through there. So it's not just a let's make sure that we've got it possible at any time. Let's be very selective on when we end up using that energy and applying that better air quality for when we need it.
Yeah, fascinating look at a lot of different changes.
There are.
All right, well, Josh, let me ask you this next one here. Traditionally, approaches like electrification, water use reduction, and IAQ they've been at odds with each other. What technology or innovations within the industry is Henderson Engineers applying to ensure that these approaches do work together instead of against each other?
Yeah, it's definitely a challenge. And, historically, we've really made decisions based a lot on ROI. We've looked a lot at the financial payback when we're trying to weigh different outcomes in those inflection points in a project. Chiller efficiency is a big one we see. The other one is on renovation projects. There's an ROI discussion usually around insulation, and so we find that we have to slightly change our way of thinking and slightly change the conversation away from just financial ROI to how does each decision kind of affect overall the environment and what we're trying to achieve from a sustainability standpoint. We have to look at each decision from what is its greenhouse gas emissions potential? What's its embodied carbon? And we have to start really changing our mindset, and not say we don't also look at the financials. That's also important, but we're continuing to, look at those other additional pieces and kind of look at a holistic approach overall to each decision. And one thing we're looking at to make those decisions and inform those decisions is data. Our buildings generate tons and tons of data. And we feel like we're really good at looking at the data and reading the data when there's an acute problem. But we don't feel like traditionally the industry has been very good at looking at data and using it to inform decisions ahead of time and look at how one system affects another. To do that, we've got teams here at Henderson that are looking at stuff like AI and machine learning to really parse through, like I said, all that tons and tons of data and see what can be done and how we can make not just solutions, but smart solutions. So as we move forward, we're pretty excited about some of those.
Yeah, it's to the point on data. One of the it's data and data management, but it's also just understanding kind of the garbage in, garbage out. It used to be that we would even talk about water and saving water completely separate than talking about saving kW and electrical energy or even kind of carbon neutrality. We always wanted to save water because it was the right thing to do. It helped the utility grid kind of thing. But now with the data that we've got, we can assign essentially a carbon value to every gallon of water that a facility ends up utilizing. So this is what's it take to source that water and where it's coming from, to treat that water, to pressurize a gridded water system, to get the water to the tap or to the chiller or to the cooling tower or wherever that water is going to be utilized. And then on the back end of that, we've got to look at it going back out the building. So we've also got then the waste stream effect. How's that going to be treated? Where does that end up kind of finding its final home? So we can still look at it from a carbon perspective, which does help inform, as Josh is saying, even those ROI discussions. It's not just going to be that dollar value. There's other weights and measures that as a group and as a stakeholder group, we can really start seeing how those levers sort of apply with each other. Saving 1 kW isn't a great idea when it costs you 3 kW elsewhere. But the same can be said with carbon. Saving a little bit of carbon might not end up being the best idea when it takes 2 times, 3 times as much carbon to get a new piece delivered to that site. Another good example that we've started seeing shift even within the renovation side of things is historically, and we'll use that, and I'm sure that we already have in this discussion quite a bit. But in a room, we'd indicate a diffuser or a light fixture. We'd say, hey, we can reuse this in the project when it's finally done. So Mr. and Mrs. Contractor, let's go ahead and pull that down. Let's clean it and let's reuse it in the final phase of the project. At initial blush, every contractor is going to look at that requirement and say, it's cheaper for me just to buy a new one. I would rather just buy a new one, get it delivered at the time that I need it and install it and not have to worry about the effort that goes into reusing this thing. And we can all see that that automatically has doubled, if not tripled, the carbon footprint of that single diffuser, because now it's going to a landfill somewhere instead of being reused. And we're building a new one, which is all the materials associated with that and the transportation carbon footprint of getting that then delivered to the site. So you can start peeling back those layers and saying, with these better decisions and simply saying, we do want to pay you to clean that diffuser and reuse it rather than paying an equal or slightly lesser value to get a brand new one. That might be that right decision. The data informs the stakeholders to make those decisions a little bit better. It's our job, it's our duty, it's our goal to kind of help inform them along the way. They'll have their weights and measures specific to that enterprise and their long-term goals. We want to make sure that we end up infilling them with the data that we can glean from all of our footprint of projects, all of our trends that we see, to make sure that even as a holistic industry, we're marching in that right direction.
All right, well, fascinating look, and thank you for those perspectives.
Yeah, thank you.
Thank you.
Yeah, I've been speaking today with Josh Smith and John Flan from Henderson Engineers about hospitals, healthcare facilities, and all of the aspects involved. Thank you so much for joining us, and we'll see you next time. Bye-bye.